Hey everyone, and welcome. If you're a Java developer and you're looking to get your hands dirty with AI to really build the next generation of smart applications, then you are in exactly the right place. Today, we're diving deep into the Agent Development Kit, or ADK for Java. This is your toolkit for creating some seriously powerful autonomous AI agents, all using the language you already know and love. So here's our game plan. We're going to walk through a structured path, starting with building your very first agent, and then leveling up to create complex, even iterative workflows. We'll cover the key design patterns that will help you think like an agent architect. All right, let's dive in. First up, let's get you building your very first agent. One of the best things about the ADK is how fast you can get up and running. There's no crazy learning curve here. We're talking about going from zero to a fully functioning agent using tools that are probably already open on your desktop. It really is as simple as 1, 2, 3. First, you just clone the ADK Java Maven template from GitHub. This is a massive time saver. It gives you a whole project structure right out of the box. Then you add just a couple of dependencies to your POM file, and that's it. You run it. You've got an agent. And when I say a couple of dependencies, I really do mean it. You just need 2. The first one is for the core ADK framework itself, and the second one, this is super helpful, it's for a web-based WI that lets you see what your agent is thinking, making debugging so much easier. It's lean, and it's incredibly straightforward. So what does an agent actually look like in code? Well, it's surprisingly simple. An agent really just has a few key parts. You give it a name, a clear description of what it's supposed to do, and most importantly, you give it instructions that tell the underlying AI model how to behave. You can also give it tools like a function to get the weather so it can interact with the real world. Okay, now that we've built a basic agent, let's get into the really powerful stuff, the architectural patterns. The first big idea is divide and conquer, right? As a developer, you wouldn't write a complex app in one giant messy class. And it's the same exact principle with agents. You don't build one monolithic agent to do everything. You break the problem down.
And this is where sub-agents come into play. Think of a sub-agent like a specialized microservice or a focused component. You have one main orchestrator agent that acts like a project manager, and it delegates specific tasks to a whole team of specialist sub-agents. It's a modular approach that, we Java developers get. It just makes sense.
This quote really hits the nail on the head. A focused agent with a single, clear job is just so much more reliable. It's less likely to get confused or go off the rails. It's predictable. And honestly, it's way easier to debug and maintain than one giant, overburdened agent that's trying to do too many things at once.
Let's look at this Content Companion example to make it real. The main agent, the orchestrator, is our project manager. It understands the user's high-level goal. So if the user asks for some research on a topic, it knows to call the topic search agent. If they want a tweet written, it calls the social media agent. The orchestrator doesn't do the work itself. It's just really good at delegating.
Okay, so delegating single tasks is cool. But the real power comes when you start automating entire multi-step processes. To do that, the ADK gives us some awesome workflow patterns that let us compose these sub-agents into sophisticated chains of logic. This brings us to 2 fundamental building blocks. For any process where the order is absolutely critical, like say a trip planner that has to find a destination before it can book a hotel, you're going to use a sequential agent. But for tasks that can all happen at the same time, like gathering a company's news, financials, and profile, you'll use a parallel agent to get it all done as fast as possible. But you're probably wondering, how does one agent in this sequence pass its results to the next one? Well, the magic is in something called state passing, and it starts with this output key. When the first agent, the producer, finishes its job, it uses this method to save its result into a shared memory space under a specific name. And here's the other half of the magic. The next agent in the chain, the consumer, can then access that data directly in its own instructions. See that placeholder? The ADK automatically finds the value saved under that key and injects it right there. This is how you chain agents together so they can build on each other's work. It's so powerful. And the true power comes when you start combining these patterns.
Look at this company detective agent. It's a hybrid. First, it fires off a parallel agent to grab 3 different kinds of data all at once. Then, it just waits for all of those to finish. And finally, a sequential agent kicks in with a report compiler that takes all that data and synthesizes it into one final polished report.
All right, we've talked delegation, we've talked sequence, and we've talked parallelism. But there's one more advanced pattern that lets us build agents that can actually problem solve. This is where the loop agent comes in. It's what lets our agents refine and improve their own work. So, how do you do it? I mean, how do you build an agent that doesn't just give you a first draft, but can actually look at its own output, find the flaws, and then fix them? This is a huge challenge in AI, and the loop agent is the ADK's answer. This code refiner example is just perfect for explaining this. It basically works the same way a human developer would. You have one agent, the code generator, write some code. Then a second agent, the code reviewer, analyzes it and gives feedback. The loop then sends that feedback back to the original agent, which improves the code. And this cycle just keeps going until the reviewer agent is happy and says, okay, we're done. Okay, a quick but absolutely critical point here. When you build a loop agent, you should always set a max number of iterations. This is your safety net. It's what prevents your agent from getting stuck in a never-ending loop, which could burn through resources and money. You got to build safe, controlled loops. All right, let's take a breath. We have covered a ton of ground. We've gone all the way from a single, simple agent to building these really complex, multi-layered systems. So let's just quickly recap these powerful patterns that really are the foundation of becoming a Java agent architect. Here it is, all in a nutshell. Think of this as your cheat sheet. Use the subagent pattern when you need flexibility, like for a chatbot. Use a sequential agent when the order of operations is key. Choose a parallel agent when you need speed and efficiency. And pull out the loop agent for those really tough problems that need self-correction. Mastering these is all about knowing which tool to use for the job.
So, what's next? It's time to build something. Head over to the Agent Development Kit homepage, clone that ADK-Java-Maven template from GitHub, and just bring your own ideas to life. Start simple, and then start composing these powerful workflows we've talked about today. The era of AI agents is here. And with the ADK, you as a Java developer are perfectly positioned to build its future. So, what are you going to create?